All right, welcome to our first lesson on polynomials. This is basically what is a polynomial and how do we classify them so we can look at them later and talk in terms of math about a polynomial rather than just saying here's some equation. All right, so here's what's going to happen. First of all, let's define a polynomial function. The polynomial function, its definition is kind of interesting in that it's just a monomial. And a monomial, the first four letters there is mono, which means one. A monomial is a single term, like x, or 3x, or 5x squared. That's a monomial. It has a single term. So a polynomial is either a single term or it's the sum of many monomials. Poly just means many. So here is the definition, the straight up math definition of a polynomial function. The a sub n terms are the coefficients. So a sub n right here, that's what's called a coefficient. Coefficient, it's right here. Coefficient is just the number in front of x. So if I wrote 3x squared, 3 is my coefficient. And the 2 is obviously my exponent. It's also called the degree of this term. Now 3x squared would be a monomial because it's a single term. 3x squared minus 5, that would be a binomial because it's got two terms. We're going to get to the many names of these things in a few minutes. All right, the big key piece here, however, is the first term determines a couple things. It determines what we call the degree, which we'll get into, and the a sub n is not only our coefficient, but what's called our leading coefficient. Leading because it's in the front. All right, let's get looking at a little bit more definition piece here. Oh, sorry, let's say this. As you notice here, x to the n is just a number. So like x to the fifth, this is a standard form polynomial because it has x to the fifth. Then we have the power 1 less than 5 because n minus 1 is 1 less than. So it would be x to the fourth plus blah, 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 like x to the third, x to the second, x to the first, and then the constant at the end. And we remember standard form from quadratics because quadratics are polynomials. Quadratic function is a polynomial function. Standard form is something like this, where the degrees of the polynomial descend. So this is 3x squared plus x plus 5. It goes x to the second, x to the first. So this would be in standard form because the exponents decrease. All right. In order to determine the degree of the polynomial, you need to look at the variable that has the largest exponent. So if the largest exponent is a 4, it is a degree 4 polynomial. If the largest degree is a 1, then it's a degree 1, or a linear, as we recall. We are going to name polynomials or classify polynomials by the number of terms and by the degree. This particular polynomial, and notice I said something about standard form here, this particular polynomial here is in the circle. This is the polynomial. The x to the third power is my largest power, my largest exponent, and therefore this is a third degree polynomial. So the degree of p of x is 3. The leading coefficient of p of x is 2. And then we can name each of the terms as we did before in the quadratic. In the quadratic, we only had quadratic, linear, and constant terms, but now we can get larger terms. In this case, a cubic. Anything to the third power is called a cubic term. So P of x would be called a cubic with 4 terms. So it's got a number of terms, which is 4, and it's got a highest degree of 3. And as I mentioned, a polynomial in standard form has exponents in decreasing order. So this is in standard form because it goes 3, 2, 1, and then constant at the end. All right, so as I mentioned, we were going to talk about naming polynomials. Naming polynomials. Here are all of the polynomials, this column right here. And they are already in standard form for us. Obviously, the ones you have to work with are not going to be. If you just have a single number, we call that a constant polynomial. It's got a single term, so we call it a monomial. And there are no x's, so the degree is 0. Notice we're going to be looking at 0 through 5. So the next one is an example of a linear polynomial. This is x to the first power. It has 2 terms. It has the x and the 3, and therefore we call it a binomial because it has 2 terms. And it's linear because it's x to the first. And the degree is 1 because it's x to the first. If you have a degree 2 polynomial, we call those things quadratics. And as long as you have an x squared, it's a quadratic polynomial. And this one only has a single term, so we call it a monomial again. So we would call this a quadratic monomial. So kind of like the last example we looked at on the last page, we have a cubic here. It's x to the third. Those are called cubic functions. This has 3 terms of 1, 2, 3 terms, and 3-term polynomials are called trinomials because tri means 3, just like bi means 2 and mono means 1. If we move down to the 4th degree, the 4th degree polynomials have special names called quartics, and that would be x to the 4th. Note this has 2 terms, and therefore it's a binomial. And the last one here is a 5th degree polynomial with the special name of quintic. Now, the reason we look at 0 through 5 is basically because we have only those as special names. If the degree is 0, it's constant. Then we have linear, quadratic, cubic, quartic, and quintic. And if we have something x to the 6th, we just simply call it a 6th degree polynomial. And notice here, we have special names for 1, 2, and 3 terms, but we don't have a special name for 4 terms. So if I have something with more than 3 terms, we just simply call it a polynomial with 4 terms or 5 terms or 6 terms, however many there are in that polynomial. So what I'm meaning down here is note that you can call this 3rd one here, or 4th one I guess is really, you could call this a cubic trinomial as a full name, I guess, for this polynomial. All right, let's go ahead and look at a couple of examples, and I will set you loose. So here, what we want to do is write the polynomial in standard form, and then classify it by degree and the number of terms. And you must remember to combine like terms first. If you do not combine like terms, you are not going to get the correct answer. So here we go. We have 4x minus 6x plus 5. Well, I have like terms right here, so I have to combine them. And I get negative 2x plus 5. And we notice that this is actually in standard form already because I don't have to move things around. The x and then the constant. This is x to the first, so it's linear. And it has 2 terms, so it's a binomial. That one was pretty simple. What about one that looks like this? We have many more terms, or a couple more terms here. But I noticed that I have two things that are in common. I have 3x cubed and a plus 2x cubed. So I need to combine those like terms. That's a positive 3 and a positive 2, so that means a positive 5. And I'm combining like terms, so I have to remain like terms, so it's still a cubic. Followed by the x squared, and followed by minus 4x. And now I look, the highest degree, actually this is in standard form because it's 3, 2, 1. The highest degree is a 3. And therefore it is a cubic. It has 3 terms, and therefore it is a trinomial. Same kind of thing here. You can always pause this to make sure you get the right answer before I do it. I'm going to go ahead and I'm going to combine like terms first. So I get x squared. I get a minus 4x and a plus 2x. That makes a minus 2x. And then I have my plus 3x cubed. This is not in standard form yet, so I need to change it into standard form. My 3x cubed needs to go first, followed by my plus. This is a positive x squared. And a minus 2x. And we notice, again, we have a cubic trinomial. So this is the same type of polynomial as the one before it. What if it looks like this? You're going to get problems that ask you to do something like this, where you are required to do a little bit of FOIL or a little bit of extra good math to simplify this problem. So 2x plus 5 squared means take 2x plus 5 and multiply it by itself again. And add 1. So when I FOIL this, 2x times 2x is 4x squared. I get 5 times 2x, which is a plus 10x. I get 2x times 5, which is another 10x. And I get 5 times 5, which is 25. And I remember to bring my plus 1 along. And here I'm going to simplify and put in standard form. I get 4x squared. That's my biggest degree. That means it's going to be a quadratic. 10x and 10x makes 20x. 25 and 1 make a 26. And this is a quadratic trinomial. Trinomial because it has 3 terms. All right, what about x minus 3 to the third power? All right, x minus 3 to the third power. Well, third power means I need to multiply it by itself 3 times. So this takes a little bit of work. We get x minus 3 times x minus 3 times x minus 3. And what we need to do is we need to FOIL it, but we need to do it in order here, or in a just piece by piece. If I FOIL the first 2 together, I get x squared minus 3x minus another 3x plus 9. And I need to put that in parentheses. And I'm going to need to multiply that by x minus 3. But before I do that, I put the big thing in simplified terms first. So I get x squared minus 6x plus 9. And then I'm going to multiply by x minus 3. So I need to multiply this x by all 3 things. So I'm going to take this x and I'm going to multiply here, here, And here, so x times x squared is x to the third. X times minus 6x is minus 6x squared. X times 9 is plus 9x. And then I need to do the same thing with the minus 3. So minus 3 times x squared is a minus 3x squared. Minus 3 times minus 6x means a plus 18x. And minus 3 times 9 is a minus 27. And then I'm going to combine my like terms so I can put it in standard form. So I get x cubed. I get x cubed, and then I have a minus 6x squared and a minus 3x squared, which makes a minus 9x squared. Here I get a plus 9x and a plus 18x, which makes plus 27x, and a minus 27 by itself. So I look at this and I say, okay, I have a largest degree is 3, so it's cubic. And it has 4 terms, so we say with 4 terms. All right, so there we have it. There's all of our examples. This will get you through the assignment. We really need to know how to name polynomials and how to look at polynomials and know exactly what kind of thing we're talking about when we talk about things verbally. All right, so there you go. I will see you guys tomorrow.